they could ship out is 220 volts, 50 hertz at, and then they have the G threading. You know, I think you get what threading? What's the threading you guys use there?
Well, there's really no standard, but plumbing is all still imperial. So anything from quarter-inch to 1 inch onwards and stuff. So
Okay.
imperial is still pretty much standard over here.
All right. You guys have somebody taking notes over there?
I think hopefully this is being recorded. And Vaibhav, Richa, someone writing down stuff?
Yeah.
Oh, okay, good.
Yeah.
Anyway, on chat, I posted a link to the gas compressor that we have a local source for.
Okay. Yeah, it's good to get local sources for sure. One thing I do want to, we've been doing this for a while, so a lot of times people come in and they'll, try to make modifications as builders and tinker around. One thing I'd recommend is that you guys kind of follow the same designs we have, due to the fact that anybody that's kind of tinkered and adjusted has had some issues, right? And then you can, modify and adjust from there. But there's always the thing that comes up a lot is aluminum sieves versus the PVC. I've run the calculations. PVC is actually cheaper, even with the labor cost of making them. Doing extrude aluminum takes a while to do, right? The adhesive that we recommend in the BOM, if you go to the Oxikit website and click on bundle, there is a downloadable BOM that has links to all of the different products in there. The Gorilla Glue, the adhesives are very important that you kind of use the same exact ones that we have in there. They have they have a water-based adhesive. It's basically a safer style adhesive. The other thing I would mention is a couple other points is when you're making the sieves, make sure that you vibrate the sieves, and I will share a link to how to make a vibrator using an old tire and a little concrete jack thing, which will help a lot. That's extremely important. You want to compact the sieves. The compression springs are also important, that you utilize 50-pound compression springs, and there's a video on how to make the components in there. I have updated the frame to be, and I think I posted the video in there. We were using 2x2s and MDF boards in a rectangle style shape, which is easier to work with. And we have actually, I need to update this. This will be a big help, which is we're using the Arduino Uno Rev 3 and the shield. We link to it in the BOM, and that just knocks out a ton of stuff. It'll save you like $100 in cost by just using basically one relay board, Arduino, the Arduino Uno, and you could load the code on there. I'll take a snapshot of the setup that we've basically minimized so that it's dead simple now. Another thing is, people complain about the noise factor, but that's just general complaint. I mean, the main thing is you want to have the output that performs. So kind of leaving it as an open shell will keep the coils cooler, right? Definitely want to use the copper coils. The longer the coil you have, the cooler the air will be as it goes through the system. Let's see what other else. Oh, pressure safety valve. You want to get a
Relief valve.
Yeah, you want to get a 50 psi relief valve that is right before the regulator. That way you can basically make sure you get the safety and the thing doesn't blow up, right? So even though we never had that issue, but it's good to have that. Let's see, what are some other kind of issues that have come up? The orifices, gosh, those are extremely important. The 1.5 millimeter orifices inside of the tubing. So what we've done, the reason we selected sodium over lithium zeolite was that lithium is extremely in high demand with like a 16-week lead times from all the good suppliers. Sodium is still has longer lead times. We have priority shipping with Honeywell as our partner in this, and they want us to kind of handle all the orders through our system. We can ship drums as well, and we have Mylar bags that we ship the zeolite in. We use sodium because it is about 4 to 6 times cheaper and more accessible. And the way we hacked it was to get really good performance is we recycle some of the air. So as the enriched air comes out of the sieves, we'll put it through what's called the halo, and we have these orifices which have a 1.5 millimeter hole inside of them. Inside the additional tubing with the direct acting valve. And what that will do is air will come back in, it'll push back into the sieves, enriched air. So you have enriched air mixed with ambient air, 21% ambient air, and you have enriched air resulting in a second cycle of the air, allowing it to be enriched using the sodium. That's kind of the big hack that allows us to utilize sodium to do this with. So I strongly encourage you guys to use the sodium 13X zeolite if you can find it there. Like I said, we can ship. You guys order the bundle. I could ship it tomorrow to you guys to India. I have DHL and FedEx has given me 81 and 85% off shipping rates. So international shipping rates, so we can get stuff over to you at air shipped at a lower cost there. So that'll be helpful. I think ordering this stuff, I think the bundles the bundle gets you like $350. That'll get you plus the shipping costs, pretty much the majority of the core stuff that you'll need, and then you can find the compressor over there. And you'll have it in this week, pretty much coming in. And then, because it takes a little while to source local stuff and figure out what works and doesn't work. We've done this a ton of times. So, and the pricing is pretty aggressive for all the items you'll need. So that's that. What questions do you guys have for me?
Okay, I have a couple. Most of the points you raised, I think we have sort of started thinking on those lines already. We ported your bomb to a spreadsheet, which is online. I posted a link. And we also linked the items that we thought were high priority in terms of, let's say, specification. So the spring, as you mentioned, the pump and so on, orifices. I had one question regarding the PVC parts study we've used in this. Have you had any concerns regarding outgassing from PVC because this is for medical use? Or
we
don't have to worry about?
You don't have to worry about that because we're using rigid PVC, right? So, and I mean, even then with the flexible PVC and tubing, there's a lot of information out there. A lot of medical supplies use the PVC and tubing. It's just something that kind of comes up, but it's really not. I mean, you could always just source from medical grade tubing and whatnot. But yeah, the tubing, the PVC rigid tubing, if you look that up, this was a discussion in Pillar Tribe in the past that's been squashed.
Okay, cool. Good to hear that.
Make sure you're using Schedule 80.
Okay.
Or above PVC pipes and fittings, for the pressure.
Okay.
And also one thing you want to do is when you're creating the sieves, you want to basically put the adhesive in the shell together and then let it dry overnight so all the fumes kind of dissipate and go away.
Makes sense.
And then you'll put in the zeolite on top of that. So, and then what I could do for you guys too is just to boost you guys, I could put in the PVC parts, the little disc, the drain, and the basically the additional fittings for the.
I think that'll be helpful. The other question I had was, I pulled on your GitHub repo, but is there a better, let's say, collection of documentation? Because I didn't find anything about how to hook up the Arduino to the various solenoids and which pins are going to which of these solenoids, for example. Or
if you go If you go to
Yeah,
hackaday.io/Oxi Kit and then go to the project in there, there is a ton of files you could download, including like more
awesome.
than 400 pages of industrial designs
Okay,
and
sweet.
the schematics and code. And there's also an oxygen analyzer setup that Krishna put together, a DIY deal that you can, so you can kind of detect the oxygen levels in an inexpensive fashion to build.
Yeah, so okay, I'm going to do that. Hackaday is kind of my territory. Also, the next question is on the analyzer part. So, you aren't putting an analyzer on each unit you're shipping, right? I mean, it's just to
Uh,
verify.
yeah, it's just to verify. We just
Right.
basically, I mean,
Got it.
the unit we have is like a $15,000, $20,000 machine. I mean, for some reason the
Okay.
military even tracks where all these units are, but we've got connects that have sent this unit. But we did find a cool one that I just now received today.
I saw
So
that.
I'll utilize it and report back, which is awesome because it detects oxygen flow and pressure, which is something that I want to test throughout the system. As the air flows through different parts, we can basically tap in and see what's going on in different portions of the system.
Cool. Awesome. Uh, what else? Okay, Vaibhav, I think the ball's in our court. We have to get cracking on ordering out stuff now.
Yes, I'll place the order right away on your website, Maher. This is the same link that you had sent me. I'm just gonna figure this out and right away make that order. The 699 bundle, right?
Yeah. If you get the bundle, and there's the compressor, but the cost of all the additional PVC parts. I'll send you guys a bunch of stuff. Just order the item, and then because the rest of the PVC parts are not in there that we have in inventory.
I'm just placing that order in the next 15-20 minutes. Done.
Awesome.
Cool.
I have
and
a
I'll real quick with DHL, one thing I'd like you guys to do is check with your customs, right? Import, you want to try to get a customs broker. I'll connect you with our senior account manager over at DHL that we'll ship with, in order to try to get all the parts through. Make sure there's no issues there with importing. I think a lot of the stuff's kind of made from China, but make this happen where it's an assembled thing. I could put made in America for a lot of parts. So that'll get through, but you just basically want to make sure you guys have an agent kind of on deck. If you get one today, it would be useful if you talk to DHL, kind of show them the BOM and what's coming in, and that way we can make the commercial invoice and packing slips and whatnot in line, with the harmonized codes, so that before we ship, it's all documentation is it'll clear customs quicker into India.
Makes sense. If anyone has insights with DHL India, let us know. I think would be useful to have some internal contact over there.
Yep. I'll connect you. I'll connect you guys with Colin. Who should I connect? Let me just do that right now while we're on the phone.
you can connect to me, Maher.
Okay. Who is
Richa?
All right.
I can
Richa,
send.
okay. What I'll do is I'll add you guys in here that I have connected, and then make the group open admin so that you can add additional folks in there. I think Colin. Here, I'll just put him in here. At Colin here. Colin. Please. Here we go. Give me a second. Connect with. Yeah, this phone is going off the chain. All right, hold on a second. Okay, connect with at Colin with DHL to receive bundle to India. All right. So put Colin Williams in the Pillar Tribe WhatsApp group. He is the man to connect with. You can send him a message there on LinkedIn. He will be probably up in a few hours. It's 2:30 a.m. here right now, and so he is very helpful and will connect you with the right folks over at DHL India side.
Great, that would be very helpful. Thank you.
Yeah, I had a question, Maya, a quick question. So in terms of certifications and approvals of this oxygen concentrator, is there something that has happened in the US?
Well, one thing we want to try to do is, well, I mean, like with FDA approval and things of that nature, they approve a specific manufacturing facility, right? So if in the strings, if you guys connect with Deepti Sharma over with LifeMech, LIFEMECH.org, they created an open source ventilator. The leads there were folks from Intel, and they got that ventilator FDA approved. So last conversations we had is they're gonna look at taking the Oxikit designs and want to bolt it on to their application that's already FDA approved to be the potential oxygen concentrator source for the ventilator. So I don't know where they're at with all that. I mean, this is, as you guys see, there's tons of people involved in all this. So I'd say reach out to Deepti Sharma. We could actually, that'd be a good question to kind of bring up in the Tuesday meeting, Tuesday, 9 a.m. PST, 11 a.m. Central Standard Time. We have a brainstorming session with Deepti, us, Adi, and then you guys want to also look at the Apollo code system, which has a MLAI code that we're working on with an ECM, I think it's called the ECM32 board. And Adi is a principal software developer, engineer for Microsoft, and him and a group of those guys and then team have been, we're working with them on having that board kind of power Oxikit to do a whole lot more functionality. Another thing we're developing right now is my developer is Azan is putting together a self calibration. Kind of created a design to do self calibration where the machine can have some oxygen sensors and run and self calibrate for the timing for the maximum output, concentration level output. We're also integrating with the global telehealth services. Another design that I kind of architected allows the user to have a Bluetooth or wired pulse oximeter that can then drive the oxygen concentrator LPMs up and down depending on the O2 sat levels. The data can also go up into the cloud and connect into the global telehealth services. So if you look up globaltelehealthservices.com, and they have done some code there. I think it's in the GitHub depository for Oxikit and Apollo somewhere in there, and that's also kind of advancing forward as well. So we have integrations. We're developing a system to go up into a database that can utilize APIs to connect into any telehealth remote monitoring service as well.
Hey, Maher, I had a quick question, if you still have the time.
Sure.
Hey, so I think I missed the part where you said, did you guys try using the sodium-based zeolites, or was it you majorly recommend the lithium-based zeolites? Because we do have a few local sources and the price difference is almost like 4x for the sodium is way cheaper than the lithium-based zeolite. Any experience with sodium-based ones?
Yeah. Yes. That's maybe I didn't communicate effectively earlier, but yes, that we selected sodium for that specific reason. The system we currently have uses sodium zeolite because it is 4 to 6 times cheaper and more accessible, and that's where we use that recycle functionality in order to basically still get that 97% output by recycling some of the air, which is actually a very kind of simple hack. But
Okay.
I don't know. Yeah.
That's
Oh,
pretty
the
cool
orifices.
because, I was talking to the sodium zeolite guys, and he was not so bullish on whether you will get high concentration levels. He was like, lithium, it's just gonna work. But I mean, if the sodium works, and I think if Anul, have you figured out the recycling hack which Maya suggested? We might just as well use the sodium-based zeolite.
Well, that's the way it is already configured. That's why the orifices are up.
It's already configured. There's
Yep.
no special.
Yep.
Yeah.
That's
And I'll
why
be
the
sending you
orifices are
guys.
there.
Yeah, and
Yeah, and
also
I'll be sending.
yeah,
I'll be
okay.
sending you guys the orifices as part of the package. You'll be getting the orifices as well to include in there. One of the things you want to do with the orifices is when you stick them inside of the tubes. And I'll send you guys pictures of the system, how it kind of connects. When you put them inside of the tubes, you'd want to get a little zip tie and wrap it around the orifice and the tube and kind of tighten it up to keep it in place.
Yep.
Okay. Yeah. There's also a talk of there's someone trying to pitch an alternate material, which is, I think it's porous silicate. Did you guys like? You would still strongly recommend zeolites only, right? If we have to.
Yeah, sodium. Yeah. Like I said, I mean, this, a lot of this has come up before many times. Strong, guys, I've spent $500,000 to get to this point, right? So burned through so much stuff, gone through so much different iterations and prototypes, and strongly encourage you to follow the system that we've developed first, and then kind of try to modify and build on top of that. That way you guys have some, a win coming out, and you don't get kind of demoralized by making some adjustments. Oh, it's not working,
Yeah, that was the whole purpose of setting up this the fundraiser and the project both, is to get a kit from Oxikit and build it as recommended, and then see what we can do to kind of improve things based on local materials and stuff like that. So
we can place the sodium zeolite order, Vibo and which I
Yep.
Yeah,
Yep.
I think,
Yep.
Yeah, there's already.
And since you'll be getting the zeolite from us to build that first machine, you could also use that as a kind of a test point for additional zeolites that you purchase over there. Once you use our zeolite, and it's high quality stuff made from Honeywell.
Another question, Maher, is this zeolite a consumable, or is it like, does it last for the life of the machine?
That's a great question. So the zeolite will last about 2 years. It could run, kind of 24/7, a year to 2 years. One thing you do want to do is for moisture and humidity control is when you have the machine off. One of the things, another little design thing I wanted to do was put in maybe in front of the sieves, some type of vacuum, little small vacuum thing to clear out the air whenever it's being stored and not used. Definitely whenever you build the sieves, you want to close the end caps where the fittings connect, so that you don't have humidity coming in. We're talking to UNICEF, and one of the issues they have is they'll put concentrators in storage, and one of the reasons they kind of go bad is they're not being used, and humidity gets inside of the zeolite. So keeping it closed, the system closed whenever it's not in use is a way to conserve it. Now the zeolite will last, like I said, a very long time. The compressor is oilless. If you're using an oilless long duty cycle compressor, then they're built to run for thousands of hours at a time before needing maintenance. And then you just basically swap out the sieve, right? To maintain it a year from now, and ever so often just kind of check the O2 output. We kind of shot for the stars and the moon, and we got like NASA engineers on here that are like 90%, above 90%, but most of these concentrators out there that you'll see, even little 5 LPMs and 10 LPMs, they'll say 90% plus, but that's really like at 1, 2, 3 LPMs. When you get up to the higher numbers on the machine, it kind of drops to 70s and 80s, whereas our system will actually do 90% plus at the 25 LPMs, right? So you could actually go up and get up to 30s. In the 30s, you're in the 80s, which is still pretty badass,
Right. Okay. Also, is there any issue with caking of the zeolite during storage? or compaction?
No, what we do is inside of the drums that we inside of the drums when they come shipped to us, they basically have nitrogen inside of them. So one thing you can do is, I mean, you probably use zeolite. You know, once you got the sieves ready, put the zeolite in, cap it off in the Mylar bags that we get. But once you guys are ordering additional zeolite from there, if you got them from drums, what you'll want to do is tap the top of the drum. And that top of the drum lid, you'd want to, here, let me just take a picture of what it is and drop it into the Telegram group, kind of what we're doing here. And so what we do is we hook it up to a nitrogen tank, right? And we basically have it at, was it like we'll have about between 1 and 2 PSI of nitrogen coming into it so that, here, let me just take a little picture real quick. You guys can kind of see how we do this. Come on, attachment, photo, yeah. Okay, so I just dropped the photo into the M19 Oxikit group, and as you can see, we kind of tap it in there with a, you know, we created this, you know, little fittings and a couple, you know, a tap out, and you could do is reuse that lid. If you would create it, you could reuse that lid as you go from drum to drum. I think we got like 300 pounds of zeolite in each one of these drums, and we'll just reuse that top. Whenever we take another top off, we pop this top on, a couple of these tops. So, and as long as you got nitrogen coming in, then what'll also happen, if you notice at the bottom there where the zeolite will come out, put a little rubber band to kind of close it so that the nitrogen pressure kind of pushes that open lid. Another issue we will have, the you know, the molecular sieve is, you know, it's kind of like very fine grained sand, so it can get kind of in between the ridges when you shut it and close it. So that gets a little annoying. So having a better, actually creating a better tap pour solution that can shut without that stuff getting caught up, because you know, push it down and really work with it to keep it from the you know, expelling air into the nitrogen out into the open. That'll be helpful. So if you store it, it's pretty good. You could store it other areas. Most of the manufacturers, if you know the local manufacturer, you want to ask them, do they ship the drum with the zeolite already, and do they basically have a nitrogen inside of the drum in order to extend the life of the zeolite when it arrives to you guys?
Okay, Praveen, we need to keep that in mind.
Yeah, I'll check with them.
And you also mentioned that you have some solution for vibrating the Oxikit so that the zeolite doesn't cake up inside the sieve.
Yeah, let me go ahead and take a picture of this stuff and drop it in here for you guys as well. It's a very simple solution, and it's just some tire wood and a little concrete vibrator deal. Let me see, where's that little puppy at? Shoveling stuff around here. Here we go.
It would be useful if we actually have an unbalanced compressor that itself can act as a shaker of sorts.
Let's see, I'm just sending this over to you guys. So this is kind of the rig, and then there's the concrete. It's a concrete, you know, basically has a bottom, it has a concrete, but we have a concrete vibrator, and then so this is the concrete vibrator we use, and then let me try to flip this so you guys can see how it's just, you know, very simple, 2 bolts at the bottom there. And I think if you guys did I mean, I got this off of YouTube. If I just put a DIY vibrator, okay, I think we would put DIY
I'll check it out.
Yeah, vibrator. So, and then here, if you look at the bolts up top here, you can kind of see how you know, we did the top section, and then that tube inside of there, we just basically get the we oversize that square a little bit, and then you put the tube inside. You got a 3-inch PVC pipe, and we utilize a coupling that is utilized to attach the PVC. We cut it, and then that'll go on the outside to catch it and position it and hold it inside of that square area. Let me go ahead and flip this guy over. Give me a second. There you go. You guys see it? I mean, it's really simple, right? So I just kind of popped in the pictures.
Okay.
I mean, that's all it is. It just basically catches and starts vibrating with that concrete vibrator there.
Got it.
Okay, let me drop it. Let me go ahead while I have y'all on here. Start dropping in some pictures of the new solution, the frame. You guys could kind of take pictures, you know, kind of analyze this thing from there. I mean, we're just kind of blowing and going. So this is the new kind of layout, structure, design. I'm gonna go ahead. I'm dropping in here. Take different angles of it for you. I took the sieves. I popped the sieves off of this, so there's only the surge tank on here right now. But you know, the surge tanks will go inside of where you'll see the little loose tubing here. It just pops on back there. We got some of the valves down here at the bottom. Yeah, this is a much kind of cleaner design than having it open. And then here we kind of take I'll take a picture of the little relay board we kind of put together here, and Arduino Uno. And this is all you'll need for the, you know, instead of that dim rail system.
Yeah.
There's that. Go around here and pop a few more pictures for you guys. And let's put this side here. We got the direct acting valve in here. Yeah, you'll be getting all these fittings and the valves as well. Gosh, man, this phone doesn't stop. I don't know what's going on. All right. Yeah, I mean, if you got you got 300,000 cases a day. I mean, that's really with a average of 2 to 3% death rate. Normally, with access to oxygen, I mean, you can only imagine what's going on there in India. You know, you've probably got numbers more closer to 6-7% dying right now due to the lack of oxygen on a daily basis. You know.
Yep, it isn't a good situation here for sure.
Yeah, it's pretty dire. You know, we've been at this for a year, kind of talking to people about this, and now it's kind of getting taken more seriously. So there you guys go. I'm kind of taking snapshots of the new kind of rig, so you guys could maybe zoom in and kind of attach. You know, like I said, the sieves do go at the top. You'll see the two loose hoses that goes at the top, and then the cylinder valves at the bottom is where they attach over to the bottom of the sieves.
Okay.
And then the instructions on how to build everything else is on the YouTube playlist.
All right, that's kind of helpful. Are there any more questions?
I've also gone ahead and placed the order. It's 140 order number. You should have it.
Great. We'll get it put together there and send it out to you guys.
Let me know. Yes, put that together. Yeah.
Okay, and I think sometime today or tomorrow, Vaibhav and the rest of the folks are heading out to buy the local stuff. So
yeah,
we'll have an insight on that soon enough, I guess.
Yeah, today we head out shopping to find as many things as we can.
And you guys said you are recording this, right?
The call today, yes.
All right, so here, I'm just gonna run through this to help you guys out real quick, okay? All right, here we go. Let me go ahead and flip my video. I'll kind of walk you through some of this system here. So can you guys see it?
Yep.
All right, here we go. So we have a high pressure regulator here. This is a elbow. You'll get these fittings. These are push to lock fittings. I believe these are like 3/8 to 3/8 connections. You have a 30 LPM flow meter here. This here is another regulator on the output side to the surge tank. It's important that you basically have this under 4 PSI. We got it down to like pretty much 1. The lower you have, the better, so that you don't have any the flow back and forth to the surge tank. This will control that. Here's your valve to check for the sieve pressures, right? Here is our concentrator hookup. We have air coming in from here. There were some filters. One of the things we did was we put these temperature gauges on the head of the compressor, if you get some of that, and then also attached it to the coil, right, to detect the temperature as it comes in. You have these are all 3/8 tubing. So here you have a 3/8 to 3/8, and then this coupling goes into the valves there. Here is kind of the halo that I'm talking about. Here's like the orifices, right? We call this the halo. So the surge tank will, the air comes out of here, it goes into this T, and then from there, these are all 5 inches. It goes into the, through the orifice, which will push half the air in here. And pushing air back into the sieve. Air will come out from here, and here's where you have the direct acting valve that's controlled by the Arduino board. So that's kind of the configuration there of what we call the halo unit. I'll kind of just walk around so you guys can check it out. So from the compressor, the air will come out of the output directly into the coil there. That's a 1/2 inch hole that's coming into a 3/8, loops up around, goes into this the regulator. As you can see, there's a T over here. There's a T right here. There's the pressure relief valve there. It goes in through here, comes out the other side there, which is this tube here. It'll then come down into a Y, which will then go down into the 2 solenoid valves, and then this here will plug into the sieve, right? We'll go up, out into these 2 tubes. The halo, they'll be basically cycling the pressure swing absorption system. And then here are the exhausts. You want this will have like pretty much pure oxygen popping out. So you kind of want to keep it, pointing away from the intake system, so you don't have more nitrogen coming in instead of the oxygen. And then we got some fans up here that we're fiddling around with, and some foam that connects into the power. We have a power supply source for that that we're kind of toying with. And that's pretty much it. I mean, it's pretty simple, right? I mean, as far as, we simplified it down as much as we can, right? And then another thing we want to probably do is play around with it. This is something we want to do. So that it comes with these rubber feet. What you want to probably do is put springs on here. We're going to be wanting to put some springs on there so that it basically, the vibration of the system is minimized. These little connectors kind of work well. As far as a simple DIY model, I was going to basically take this and rebuild it in a new frame and make it, a little bit cleaner and whatnot. Actually, tonight. So another thing is you'll have the output here, the water, the what's it called? Here you have the kind of where the condensation will come out of. You just want to make sure you got a place to position it there. So hopefully that little video there is you get, kind of go around it. You guys could pause the video and take a look. The different components in here. If you have any questions, kind of let us know. I know that those are 3/8 down there. These are, I believe, 3/8 to 1/4 inch. The specs will specify what exactly they are. So there's kind of a little configuration right now. I know it's a little all over the place, but like I said, I'll clean it up get that over to you guys as well. Tie straps are great. You know, we just use those to tie in everything. Let me see if I could show you guys. You know, here's all of our kind of sieve components over here. Building some here. So yeah, like here's, you know, like we attach one here. You want, you know, use the threading, some thread glue. Put this on. You want to put this on the day before you put this zeolite in. You know, here we cap off, you know, the tips. This is what I'm talking about here. You want to cap off the tips because this has zeolite inside of it, right? Yeah, so I'll be sending you guys this, you know, the parts you'll need to make the sieves and the little fittings and whatnot. So you guys have kind of everything that you need. You know, we got all the inventory here. So
Awesome. Thanks for doing that.
cool. Any other questions, gentlemen, ladies?
No, I'm pretty clear. Just waiting to get the parts on hand so we can start building it.
Okay, nice. And you know, other resources, I'd say definitely reach out to Adi. He's been very helpful leading the Apollo team there. And any questions you can post inside the Pillow Tribe groups. It is an open source, you know, project. I would ask if you guys could kind of sign up on hackaday.io, the Oxikit project. I know the Hackaday leadership team has us doing a Hackachat session that you want to mark your calendars for, which is May 5th at 12 p.m. PST,
Great.
12 p.m. PST. Yeah, so that's that session. And then of course we got the session coming up, you know, Tuesday, I guess tomorrow or something, you know, on where we got a lot of different alliance partners coming in. OSMS.org is another group that has been tracking all the different COVID, a variety of different COVID projects. They have 75,000 members on the Facebook page. Angela Forbes is who is the medical director over there. She's actually going to probably be flying in here to Houston, and we're going to be working together on some streaming projects. And so she's another good resource to connect with in the group. Who else are some good folks? Ben Coombs is another one that's built some stuff. Krupa Srinivas is another awesome resource. She also built her and Ben, I forget his last name, built Oxikit here in the United States as well. Gosh, this thing's been built all over the world. I don't fully know what's going on, but if you can go into the Hackaday page and you guys can start like kind of loading up your work and driving more traffic there, we'd like that to kind of be the central communication public depository for moving this project forward. One of the reasons I kind of waited for posting it up there was I wanted to give everybody a head start into the solution. So you're kind of starting off almost at the end to really take it up a notch, because when you're doing open source, people get burnt out over a little time. So having this starting point allows us all to really innovate and kick butt, especially with the automation that we're doing. Once you get the system rolling, one thing that we could use some help with, and this is kind of just testing, and it's 1/1000th of a second is off, is the timing. You could go into the, log into the Arduino panel while it's running. I'll go in there and I'll adjust the timing parameters to kind of get that magic timing that'll work. And it's really a lot of kind of trial and error. That's why we're creating some of the automation, this automation algorithm to kind of catch those points for those machines.
Thanks, Maher, from all of us.
You're very welcome. One thing I would recommend you do, especially if you get a 270 LPM machine, remember it's the higher the PSI, the lower the output. So you want to ask them, what is it at 2 bar, right? What is the LPM output at 2 bar that the compressor puts out? And we had 270. So we hit at 170, we hit the 15 LPM, attaches 270, hit 25 LPM. Talking to my engineer, we could actually, according to the sizes we have, I'll be sending you guys, in that bundle, 10 pounds of zeolite. 3.3 pounds is utilized in every sieve, but you could actually probably use the 5 pounds if you extend the sieve by about 3 to 4 inches. and put more zeolite in. And if you got that powerful compressor, then it could actually produce even better. That's just something we kind of got to in the last month or so. Once we got this, kick-ass 270 LPM compressor. I actually got a 300 LPM custom one being made right now that we're going to be testing. We think we could probably get up to 40 with that machine. Oh, another big one. This is very important. On the output, you do want to have a humidifier, all right? And I'll pop this inline filter for you guys. You want a humidifier in the system before it goes into the mask. The reason being, you don't want dry air going into the lungs at the bottom. It'll dry it out. So you do want to have humidified air. You put the output, your little bubbler, which I'll send to you guys. And then we have, where's that little bubbler? Over here somewhere. It's like a bubbler like this,
Yeah, most hospitals already have it, but it's good to have one on this as well.
Yeah, and then having the inline HEPA filter is very helpful as well. It'll be a new kit, in your bundle when we send it over.
Alrighty, that's awesome. All excited.
So Anul, I just had one question.
Yep.
Which was for Maher, obviously. Is the kit that you made in the USA, is it, what kind of relative humidity you're talking about? Because in the next month or so, we're going to have very, very high levels of humidity in India.
Sure. Houston is extremely humid. I mean, we had, we're talking about 90% plus humidity. We ran the machine inside of a hot, humid garage for 20 days, 24/7.
Okay, good. So that's about what we'll expect in India, except slightly higher humidity.
Yeah.
But that's okay. I mean,
so long as that machine is running, it's not an issue. As long as you cap it, make sure that that if you somehow cap the hoses before the sieve and top and bottom whenever you're storing it and not utilizing it to keep the humidity out. If you got air running through it all the time, then that's not an issue. It's usually whenever you store it.
right. So it doesn't damage the zeolite.
No, the humidity. I mean, if you get moisture inside of the sieves, that's not a good thing, right? So we overpacked it. So the input is kind of like the first part is like a sacrificial layer of zeolite. Some others use different alumina, like a desiccant, but might as well just put zeolite at the bottom as the sacrificial layer.
Right.
And you will notice once it runs, you will have some condensation on the outside. However, we were able to run it for 20 days, 24/7, and still produce those results.
That's great. I was worried about that.
Yep. Yeah, because we basically we put more zeolite in it. I mean, a lot of the systems out there are they're getting very efficient with smaller. They get super duper efficient. With the need in the world right now. Just put in overpack it a little bit more, but over engineer it, and that solves a lot of problems.
Yeah, yeah.
And by the way, guys, if you have the recording, if you could maybe drop it inside of the Pillar Tribo Tech group as well as the other groups in here, so other folks can benefit from this, it'd be helpful.
Yes, we'll do that.
Nice.
All right, let's get to work.
Awesome.
So thanks very
Thanks,
much.
Maher. It was awesome. Thanks.
You guys have a fantastic day.
Thanks
Peace
a
out.
lot. Bye.
You're welcome. Bye-bye.
Thanks, man. Thanks for everything.